And this project is focused on developing a dynamic modeling toolbox to support strategic planning in defense capability design. The starting point for this project, or the perspective that we come from, is the capability performance, whether we are talking about submarines or aircrafts or any other capability. Its capacity to meet performance is actually a dynamic system, complex and dynamic system. And the performance of this system emerges from the resources that make up this capability, the way that this capability is being managed, and the future conditions under which this capability will be operating. So that's a dynamic behavior. That's not the static. That's as the organization builds its resources, depletes the resources, maintains these resources, we expect that the performance of the capability will change over time. And this dynamic behavior is cannot be simply predicted. As Shane talked this morning, our mental models are limited, especially when it comes to understanding complex problems, feedback loops, delays. So our ability to predict how the capability will perform is really limited. So we think that there is an opportunity for a modeling toolbox which can support the capability managers in understanding these complex causal relationships and see how they influence the capability performance and how they can be changed. So this is the perspective that we come from. This has inspired the development of the modeling toolbox. And when I say the modeling toolbox, it actually includes an array of modeling techniques, mapping techniques, simulation, optimization. And the purpose of this is to give the user the power to design different systems, capability systems, run them over time, see how they behave, and compare different designs. So we would like to see how performance, for example, availability, will change in effect of factors such as requirement, different scenarios about the availability of resources, different management decisions, different constraints. So what we would like to do is to be able to look at the combined effects of changes in these factors and how they influence the capability performance. This is an overview of the modeling toolbox and how it sits within the existing analytical and planning tools in the organization. So the toolbox, there are three pillars for the toolbox. There is the mapping tool or the capability system design tool. And the purpose of this tool is really protect the user from having to understand everything about the inner working of the model. So it makes the models more accessible by giving the end users a tool that they can use to develop a capability design, which is translated into a causal scenario. Victoria this afternoon will take you through the progress that has happened at this front. The center of gravity of the modeling toolbox is the capability assessment tool, which is a simulation model, which takes scenarios directly, whether from the mapping tool or directly from the end users, and simulate them over time, see how this relationship play out over time. So the purpose is to look at different performance indicators, compare different designs. On the top of the simulation model sits the exploratory and optimization techniques, which is pretty much what it does. It says if we can use these simulation models to produce large number of simulation runs, we can start pruning, interrogating this solution space to drive some decision insights. Inayat, in the next presentation, will take you through the details of the exploratory modeling side of the toolbox. For the rest of my talk, I will focus on the centerpiece in the modeling toolbox, which is the simulation model. Why it is the centerpiece? Because that's the engine that links the input and output and generates the performance of the capability that is input to other parts of the modeling toolbox. And any insights and results that are gained from the toolbox feed into other planning and analysis techniques that are in the organizations. For example, more high fidelity, operational, scheduling, planning type tools. So I will focus on the capability assessment tool. So our vision for the capability assessment tool is to be a generic tool. So we can use it with different type of capabilities, aircraft, submarines, ships. But to be able to realize this vision, the way we approach it is through case study-based approach. So cycles of development where each case study we learn and it feeds into the design of the generic tool. And today I would like to share with you one of the case studies that we are working on as a way of reaching this vision, which is the future submarines case study. So I would like to use this case study to show you the design of the model and some of the insights that can be generated from it. This is a high-level view of the model. If you look at the model and you're familiar with stocks and flows representation, you find at the center there is the total subs available. That's the stock that the capability users managers are interested in managing. And if you look at the submarines as a stock, it gives you a sense of where are the processes that you need to manage to be able to manage this stock of resource. And there are a number of different processes. And what we do in our modeling toolbox is we give the user a number of components which allow them to manage this process and look at how different decisions will influence the rate by which this process change, and therefore influence the stock, which is the number of subs. So for example, on the top, we have the acquisition module and the retirement module. We give the end user the option to set up different retirement and acquisition schedules and see how they would change the sub-stock. And this is very important for the subs case study because they are interested in using this model to look at the transition period between the old fleet and the new fleet. This tool allows you to do this. There is also other mechanisms which influence the subs, things like the maintenance, which take the subs offline, and then when it is finished, it brings it back online. This is the feedback loop here. And in our modeling toolbox, we have a number of maintenance modules. Why a number? Because there are different maintenance types, different starting conditions, ending conditions, effects. And we give the end user the ability to build up different maintenance regimes, for example, condition-based, calendar-based, different duration, different constraints on the maintenance cycle, different requirements and effects on the fleet. So this allows the end user to test how different maintenance regimes influence the rate by which the subs come back to work. But how well the maintenance activity actually works is depending on the resources that is needed to accomplish the maintenance process. In the current version of the model, we are looking at two types of resources: the infrastructure, which is the docks needed to do the maintenance, but there is also the industry manpower. So what the model does, it allows the end users to set up locations for the docks, associate them with industry manpower, set constraints on the availability of the manpower by skill type. So not all skills are needed for all maintenance types, and the capacity for docks to undertake a particular maintenance type. So all these decisions can be made by the end user. And the relationships between these resources influence how fast the subs will come back from maintenance. But that's not the whole story, because it can come back from maintenance, but still doesn't go straight away for operations because it has still to wait for crew to man the subs. And this brings the left-hand side of the diagram, or the other stock that need to be managed, which is the crew available. And what we have in the model, we have a training module, which captures the training pipeline and how fast the training pipeline generate crew, so they can actually man the submarines. And there's a number of feedback loops here. For example, if the subs wait long time before they are able to go to operations, this means that there are less trainees generated, which means that over time there will be less crew to man the subs, which means more waiting time. So that's the beauty of this modeling approach. It gives the decision maker a holistic view of the interactions between these different resources, capturing the feedback loops, the delays, and giving the user the option to play with the decisions to influence these interactions and see how they play out. So that's the conceptual model underlying the simulation. In terms of the model functionality, the model has Excel interface, input and output. So the user can set up a number of scenarios through a simple Excel sheet, and they can decide on whatever variables you would like to look as an indicator of the health of the system, again, in Excel sheet. And this is useful because of the classified nature of the data that we have to deal with. The model runs on a Java applet, so we don't have to worry about licensing and installation issues. It also allows the user to build up to 20 plausible scenarios. And the scenario is pretty much a version of the reality, version of the future, how it look like. And that's powerful because it gives the user the ability not only to model the system as it is now, but to stretch their mental models and think of how it can look like. So, for example, they can build docks in places which doesn't exist at the moment. So the idea is to get the user to think about where are the constraints in the system. Resources are constraints, whether it is industry manpower, docks, wharves, crew. And they are layers of constraints pretty much. But where are really the points? What is my next constraint? This is important because it gets you, the capability managers, to think about what do I need to put in place to avoid hitting this constraint, or what is the cost-benefit analysis if I would like to uplift this constraint by, for example, investing in additional dock. So it gets people to think outside the existing system and construct version realities of how the system can look like. So it can be used in business casing type of analysis. This is, I'll show you one of the graphical user interfaces that we have in the model. At the moment, we have modest graphical user interface, and the focus is really on using the graphical user interface as a way to validate the model behavior, especially when the analysis and the post-processing happens off-site with classified data. So this is one of the screens that we have, and what it does, it shows the user where are the subs at every stage in their life cycle, and that's not static. These subs will move according to the changes in the simulation. So the user can set up the experiment lens as they wish and see how the subs will keep moving. On the right-hand side, the user can also have a visibility of the resources or the constraints, whether it is the number of docks available and the manpower available, the trainees, the crew available. So it gives the end user the visibility of the changes in the resource status as well as the changes in the fleet dynamics. This is another diagram or screenshot that is generated through the simulation. Again, that's a static screenshot, but in the model, it actually changes over time. It shows the fleet, the status of the fleet over time. So, and just by a quick snapshot, you can get a sense of what is the dominant feature of the fleet behavior. For example, most of it in this particular scenario is some of them are green. You don't want to see greens because it means that the subs are waiting. So this changes dynamically and allows the user to see how the fleet changes status, but it also, by just looking on the spot, it gives you a sense of the system. So this is just examples of screenshots or graphical user interfaces that we have in the model. But literally, we can stick a pin in anywhere in the system and generate a behavior over time for any of the variables that the user is interested in. Things like total waiting time per maintenance type, number of crew used in every maintenance type. So we can generate as many indicators. At this stage, our client tells us what are the indicators they need, and we generate them in the Excel sheet. But our vision for this is actually as soon as we get a good understanding of what are really the indicators and the value functions that the end users care about, it becomes embedded part of the modeling toolbox, generated automatically, and back to the capability design tool, it becomes part of interacting with the modeling at the beginning. So user has to set up this as a part of the design that Victoria will talk about later this afternoon. But this is what I would like to show here, just an example of a scenario that we run using dummy data, just to give you a sense of what is the type of insights that can be gained by running the model. This shows the availability as a percentage, availability of the sub as a percentage of what is required. Two different scenarios. In the dark blue scenario, you can see that you can achieve, sometimes you can achieve up to 90%, more than 90% availability. The light blue scenario is worse. But what does it really tell you is, the purpose is not to tell you exactly on October 1st, 2017, this will be the number of subs that you will have available. That's not the purpose of this model. The purpose of this model is to get the end user think about what is the patterns of behavior that they are seeing and what are the conditions that led to these types of behavior. So for example, why we are seeing these troughs in the behavior, what are the conditions, what was in the scenario that led to this type of behavior? In this particular scenario, we played with the delay, the time taken in the training pipeline, and you can see how it influenced the behavior. So the idea is to improve the user mental models about the system, get them to think of, if this is the conditions, the wicked conditions that can influence performance, how can I avoid it? Well, I would like to share with you some of the learning insights that I have gained through the project, not only on the model itself, but also on the modeling process. The modeling approach has a lot of merits, and the first one for me, it's top-down approach. It starts by the strategic assumptions that the users have about the capability design, how the future will look like. It allows the end user to ask these what-if questions and see the effects. And this sets the focus of the analysis on what needs to be done rather than what needs to be replaced. The conventional mental models of we need to replace this capability by this capability. But this tool actually takes you to the strategic assumptions, square zero. Why are we trying to do this? What are the objectives? And is there other ways that we can achieve these objectives? It's the dynamic analysis aspect which is really powerful because it allows the end user to see how the capability performance change over its life cycle. See, this holistic life cycle view is really powerful. And unlike the steady state traditional type of modeling where we start by the assumption that we will meet the capability requirements, we actually here say, no, we don't know if we will meet it or not. Let the model tells me if I'm going to meet it or not. I will set up the scenarios and the decisions that I may take, and the model will generate the dynamic behavior. Comparison of different capability systems over time, ability to show different performances and compare. As I said before, it gives the opportunity to do business case, justify why do we need to do this extra investment, where are the resources where we need to put more investments, and the trade-off points between this. This brings more evidence into this trade-off analysis. On the modeling process side, I think the approach that we took is rapid prototyping approach. So it took us 8-10 weeks to build up the model and get the results. And really, the key success factor in this is the clarity about the business rules. The conversations all the time between the modeling team and the client was focused on the business rules. I copied here a snapshot of the document that we have been using as a dialogue tool between the team and the end users about the business rules. What really matters? And how these business rules are translated into modeling assumptions and agreement on this as we go. Why is this important? Because it protects you, protects the modeler against some tendency to build complex models, which can be self-defeating the purpose in this particular case. You don't want the model complexity to grow beyond what was the purpose for it at the beginning. So by focusing the conversations all the time on what are the business rules, how it links to achieving the objectives or the questions that this model is trying to answer, it gets us from drifting into adding complexity and detail that may not be needed. The old mantra, validation is an ongoing process, definitely it is. And that's part of what we are doing here is by transparency about the business rule, how they are translated into assumptions in the model, uncertainties related to these assumptions and how they influence the model. This is what really builds the confidence in the client's confidence in the model and how it works. And I would say this is where many of the lessons has been generated through the modeling process. The approach is really transferable to other areas. As I said at the beginning, our vision is to take this to other capability systems, and our vision is not to be a case-specific model. We would like it to be a library, basically, where the end users can use to build models, drag and drop these modules, connect them, and build models. So we are using defense capability as a test bed for these ideas, but I think that the lessons that can be generated from this project really transcends to other applications and domains, how we can build domain-specific libraries and make models more accessible, more usable. That's definitely something that we would like to contribute to in the general modeling and simulation space. So I think that's all from me, and I will leave it here. Thank you. Have I kept myself on time? Okay. Questions?
Hi, Sandra from DST Group. Just curious, so the example you gave is for a particular platform type. Have you considered extending this modelling so you're looking at more of a capability that has more than one type of platform?
Exactly, that's on the cards. Exactly, that's part of our vision. But we have to build this cycle first where we understand how one system works before we actually take it to the next step. But that's definitely on the cards.
Hi, Saunders.
Hi, David.
I noticed on your timeline it starts at acquisition. Do you take into account planning for acquisition?
No, at the moment, the subs enter the model when they are acquired. That's the starting point.
Just in the case where you get a capability to replace capability, so you're ending one life cycle, going into another one. Otherwise, you might get a gap where you lose skills in training and crewing and things like that, which is currently what's happened with the current submarines in the future.
Yep. Well, David, I agree with you, and this is one of the points that was raised through the modeling process, but it was put on the next step aspects. We're sort of getting this first useful model. They have clear questions about they would like to come, and then revisit, adding more details, tackling the issues that you described, pre-acquisition.
Okay, thanks.
Sandos, I assume the model factors in some sort of bathtub effect at the end of the platform's life cycle. And does it also potentially incorporate mid-life upgrades and what they might do to serviceability rates?
Yes, yes. Okay, you go ahead. Well, at the moment, it's the IT resource is not considered, but again, it's part of the things that came especially in licensing. When they do licensing, at the moment, we just assume that we only need the man crew to start the licensing process. While exactly as you say, there might be some IT issues that prevent the licensing process or the ability to undertake a number of licensing processes in parallel. So this might put a constraint and add to the total waiting time. So that's an extra level of detail that we have to investigate if it is worth adding to the next level.
So how do you decide how far to go down with your modules? So for example, your training module, there's obviously some recruiting. You could perhaps have a recruiting sub-model. but then you've also got your maintenance model, module that also has a training aspect to the maintenance staff as well. So how do you decide how far to go down and then still make the results of the overall model valid?
Yes, so the idea is we start by as simple model as possible, including the business process that allow us to answer the research questions. When we do the sensitivity analysis, if it turns out that the model is sensitive to some particular parameters or the performance or the input from particular modules, this gives me a signal that this module need to be clear, more in-depth analysis, more modeling, more details. For example, in the training pipeline, we have a very simple training pipeline module. But when we run the model's behavior is very sensitive to the behavior of the training pipeline. So the next step in the project is actually focus on this training pipeline, adding more complexity details that allow us to understand this process and how it will influence the behavior. So it's starting by a broad model at a level of complexity that is sufficient to address the questions, and then use the results from the experiments to guide us into where should we build more complexity.
Thanks. Very interesting talk. Thank you. The question I have is one of the very early slides, you had a simple stock and flow diagram that was obviously very aggregated compared to the underlying model. And so two questions really. One is, it seemed to me that diagram, that simplified diagram, was something that the participants or users of the model would be able to see. Is that right?
That's true.
And then how did you decide what the right level of aggregation or simplification was? I'm curious because some of the stages in the stock and flow structure that you then showed in subsequent slides, it indicated there was a much richer main chain stock and flow structure around submarine maintenance and so forth. So how did you decide what the right level of aggregation was? And are you going to test whether different levels of aggregation add more insight for users?
Yes, so your answer to the first question is how to decide on what is the level of aggregation that you can use. And it's basically driven by what the end user think that's the useful message to communicate to people. So for the useful message in this particular graph was the relationship between maintenance, resources, feedback loop, which influence this. That's the key message they would like to send back to the client would like to send back to the end user. So that's why we structure the output from the causal loop diagram based on this idea. So that's the first one. The second one, yes, once we add to the next, because now we are working on one level of aggregation, really. Once we add the second level of aggregation, then the question can be, is there really any additional insights that we have gained by doing this process? I don't think we are in a position to answer this now. We have to travel this road before we can see. But as I answered the last question, some parameters in the model and some modules are really significantly influencing the behavior, which give us an indication that yes, perhaps adding more details, more levels of aggregation into this particular module, it can actually influence the behavior. But yes, I think that's definitely an area which we can explore.